Step 1, this little cute cylinder is going to fall off this ramp, and the gravitational potential energy of the cylinder is transferred into kinetic energy. And step 2, the cylinder will hit off the first book, and the books will fall just like dominoes. Step 3, the last book will fall, and it will hit the ruler from that end. And as you can see, when you hit the ruler from that end, it's going to turn on the switch of the kettle. Step 4, the kettle is turned on, and it's going to boil the water in it. And electrical energy is transferred into internal energy, and it's also transferred into sound energy because we can hear the water boil. And step 5, the steam will eventually rise up and it will hit the lid off. And in that step, internal energy is transferred into kinetic energy. And step 6, the lid and the baking soda inside the lid will fall off this track, and it will fall into a mixture of water, vinegar, and soap. And in this step, the potential energy of the baking soda and the lid is transferred into kinetic energy. And step 7, the baking soda and the vinegar and soap, the mixture will react, and chemical energy is transferred into kinetic energy. Step 8, the foam will rise up and will hit the lid off, and the lid will fall onto the trigger of the mousetrap. And in this step, the potential energy of this thing is going to be transferred into kinetic energy. Step 9, the mousetrap is going to pull the string, and elastic potential energy of the mousetrap is transferred into kinetic energy. And step 10, the string is attached to a hairdryer, and as the mousetrap pulls the string, the hairdryer is turned on and it's going to blow wind. Electrical energy is transferred into wind energy, which is in essence also kinetic energy. And electrical energy is also transferred into internal energy because the hairdryer releases heat. And step 11, the hairdryer will blow off this book on this suitcase, and the book is going to fall. In that step, the potential energy of this book will be transferred into kinetic energy. And step 12, it will hit this book, and they will also again follow another domino, and the last book will hit this pack of juice. And
Step 13.
This pack of juice will fall off, and it will hit that end of the racket. And in that step, the potential energy of the pack of juice is transferred into kinetic energy. And step 14, the racket will be hit up like that, and it's going to rise with a bird on it. And in that step, kinetic energy is transferred into gravitational potential energy of the bird and the racket. And step 15, as the bird rises, before it reaches its top, kinetic energy continues to be transferred into potential energy. And after it reaches its top, after it passes its top, gravitational potential energy is transferred back into kinetic energy, and it will eventually land in this ball. So for my first calculation, I calculated the efficiency of this ramp. I got the mass of this cylinder by just putting it on the scale, and it showed me it's 2.2 kilograms. I found the distance the cylinder travels from here to here, and it's 30 centimeters. I also got the height from here to here. It's 18 centimeters. I also found the time by just taking the time difference from my video, and it's 0.53 seconds. And that's also the way I found the time for all my calculations. And after that, first thing I did was to find the potential energy before the cylinder goes, and using the formula Eg equals mgh, and when I sub in the values, I got 3.88 joules. Then I found the final velocity right before the cylinder leaves the ramp by using the formula Vi plus Vf times t over 2 equals d, and I got Vf equals 1.132 meters per second. And then I used the formula for kinetic energy, Ek equals 1 over 2 mv squared, and I got it's 1.41 joules. And finally, I used the formula for efficiency, energy out over energy in times 100%. And when I sub in the values, it gave me 36.3%. The second calculation I did was for this kettle. I found the power of this kettle by just looking at the bottom of it, and it is written that the power is 1500 volts. And I also got the time the kettle boils before it hit the lid off, and the time is 327.49 seconds. I found the time by just looking at the time difference from my video, and for the first calculation I did for this kettle was to find the current through it, and I used the formula I equals P over V, and when I sub in the values I get 12.5 amps. And I also found the energy it spent before it hit the lid off, and I used the formula W equals PT, and when I sub in the values I get the energy it spent was 4.9 times 10 to the power of 5 joules. The third calculation I did was for this hairdryer, and I found the power of it by just looking at the handle of the hairdryer, and it says the power is 1875 volts. And I also found the time difference, which is 1.25 seconds. And the first calculation I did was finding the current. I used the formula I equals P over V, and it gave me 15.625 amps. Just to mention that I found the V by just knowing that the house voltage is 120 volts, so I used 120 volts for all my electrical equipment. And I also found the energy it spent before it hit this book off, and I used the formula W equals PT, and I got the energy is 2.34 times 10 to the power of 3 joules. The fourth calculation is for the projectile motion of this bird, and I tried to calculate the final speed of this bird before it hit the bowl. And I actually found the point when the bird leaves the racket, and that's the starting point of my calculation. And I measured the height of the bird at that point, and I measured the horizontal distance it travels, and I got the distance is 2.1 meters, and the height was 0.3 meters. I also found the time by looking at my video, and the time difference is 1.1 seconds. We also know that the acceleration of the bird is negative 9.8 meters per second squared. First thing we do is we find the horizontal speed of the bird, and we just use the formula Vx equals delta d over delta t, and when we sub in the values we get 1.91 meters per second. And then we find the final velocity of the vertical components. We use the formula delta d equals Vf times delta t minus 1 over 2a delta t squared. And when we sub in all the values, we get the the final vertical velocity is negative 6.229 meters per second. And to find the final speed, we just use the Pythagorean theorem, and we get 6.59 meters per second.